Hi everyone, this is your struggling CS student, and today I'll be solving another LeetCode problem. Let's take a look at today's problem. LeetCode problem 2559, count vowel strings in ranges. Okay, so it's a medium problem. You're given a zero index array of strings words and a 2D array of integers of queries. Okay, each query, queries of I left right, asks us to find the number of strings present in the range left to right, both inclusive of words that start and end with a vowel. Return an array answer of size queries.length, where answer of I is the answer to the ith query. Okay, note that vowel letters are A, E, I, O, U. 0 to 2. Okay, let's take a look at some examples. So in this case, 0 to 2, there are two strings that start and end with a vowel. Okay, so you have this one and this one. BCB doesn't end with doesn't start or end with a vowel letter. Okay. Yeah, A and E. Okay. 1 to 4, index 1 to 4. Okay. Then 0 is 1 and 1, index 1 and 1. Okay. Okay, so let's take a look at the constraints first. So words.length is 10 to the power of 5, and queries.length is 10 to the power of 5. So the first thing that comes to mind is the idea of a prefix sum. And what we can do is essentially keep track of the count of strings that satisfy the condition, where it starts with and ends with a vowel. All right, so we can pre-process words first, build the prefix sum of the count of strings that matches that starts or ends with a vowel. And afterwards, you can process the queries, so that will take all words and all query time, which is basically linear in general. So what does that look like? Let's do a dry one. Let's say, given this example, maybe we don't need to write it or draw it out. And then this is the queries. This is the queries. We can build a prefix sum first that will basically do a consecutive count of the number of strings that starts and ends with a vowel. So in this case, the first word here starts and ends with a vowel, so it will be 1, and then but this one doesn't, then it will be 1 as well. Here is 2, here is 3, and here is 4. Then what we can do is, for each query, for example, let's say 0 to index 2, in this case, well, it will be just this sum here, because this sum here represents the cumulative count from the start of the array to, well, index 2. For queries 1 to 4, then what we can do is we just need to know the subarray sum for index 1 to index 4. In this case, it will be we'll take 4, which represents the whole the sum of the entire array minus of this one, and then minus of the subarray sum of just index 0 in this case. So there will be 4 minus 1, you get 3. Your index 1 of 1 is actually 0, so well, you just need the subarray sum of this, but then you have to exclude this itself. It's a little bit hard to explain. Actually, it's not that hard. Basically, if the left and right is the same, then we just need to check for the string itself. We don't have to do some computation, but let's see if we can do some computation. Anyways, that's how this problem is solved, or that's my approach. Let's see if we can implement the solution. Right, so I have result, and then we have to build our prefix sum first. Prefix sum is like this. Let's define a helper function, starts and ends with a vowel, takes in a string, and it returns true if the string starts or ends with a vowel. So let's define vowels as a set A, E, I, O, and U, right? Then all we need to do is starts with vowel equals to S 0 in vowels, and with vowel is equals to S of -1 in vowels. So this just checks if the first and the last characters starts or ends with a vowel for a particular string. So return starts with vowel and ends with vowel. Okay, now here we just starts and ends with vowel of words of 0. So starting from the first word. This is like this. And for I in range, so now we iterate through the words list or the words array. Maybe not end. Let's do length of words. Starting from index 1, prefix sum dot append prefix sum -1. Here we're just accumulating the count. Starts and ends with vowel of words of I. And now we can build a result. So for left, right inquiries, rest.append prefix sum of right minus prefix sum of left plus starts and ends with vowel of the left side, which is words of L, I think. Could be wrong. Let's do a try run. It passes the sample test case. Kind of confident this will work. Okay, let's analyze the time and space complexity of this solution. Passes the sample test case, but yeah, I'm quite confident. Okay, so here the time complexity for this for loop is O of words, because we're just doing a one pass scan on the length of words to build our prefix sum. Our prefix sum itself takes ON space or O word space if you want. And the starts and ends with vowel helper function. The time complexity is O1 because we are just checking if the first character and the last character of a string belongs in our vowel set, and our vowel set takes up constant amount of space. This is O1 operation. This is also O1 operation, so the time complexity for this function is just O1. Here, as we iterate through the queries, we are just checking through our prefix sum and performing some sort of computation on the prefix sum to append the answer to a result. So this takes all queries time, and then return the result finally here. Is it possible to have an empty string? Words of I.length is at least 1, so you can't have an empty string. So we don't have to handle the empty case. I'm just going to YOLO submit this, see if it works. Okay, we got accepted. We got a 7-day streak. So let's take a look at the editorial today. And let's see the analyze complexity, see what's the time complexity. LeetCode says ON, yep. Space complexity also ON, yep, exactly what I said. So let's take a look at the editorial. Count vowel strings in ranges, approach, prefix sum, which is basically the approach that we had. Just reset the code first. Put the solution up here on the left side, like so. Okay. Why subtract L minus 1? Okay, this just depends on how you want to calculate the prefix sum computation. Let's see. Vowels, prefix sum 0. Yeah, okay. Yeah, okay, that's fine. Prefix sum query 1 minus so the right side minus the left, and then they handle the 0 case. Okay. If the current query of 0 is 0, okay. It's only easy for some people because of it follows very crucial dependent on obvious. Yeah, I would say if you don't know the concept of prefix sum, this question could be tricky. So yeah, should be marked easy but not obvious. Okay. But maybe I can just talk a little bit about the idea of a prefix sum and how prefix sum can help us. If you already know the idea of prefix sum, we can just skip this portion. So suppose we have a bunch of numbers, I don't know, like maybe 2, 7, 3, let's say 4 and 10, right? The thing is, how can we check the sum of a subarray given this array, right? Well, you can say, let's say given the boundary ranges left and right, say left and right here, we can just compute this sum again and again. What if I move the queries to this instead? Then you say, okay, maybe we can compute the sum like this, right? So there's a lot of repeated computation. As you can see, we're adding 3 and 4 2 times in this example. So what you can do is, instead, you can find the sum of a subarray in all one time if you use a prefix sum. When a prefix sum, you just maintain a cumulative count as you go from left to right. So in this case, it will be 2 plus 9, plus 7, which is 9, and 9 plus 3, that's 12, and then 12 plus 4, 16, and then 16 plus 10, that's 26, right? So now, if let's say, hey, you want the subarray sum from index 1, 0, 1, 2, 3 to index 3, what you can do is, well, you know that the sum here at 0, 1, 2, 3 at index 3, right? 16 actually represents the sum of this field, or rather these elements from index 0 to index 1, 2, 3 to index 3. So what I can do then is you can take this sum and can subtract off the cumulative sum for this, in which this case this is just 1. But if you take 16 minus 2, you get 14, which is actually equals to the sum of this subarray. Maybe you can use another example. Let's say you want to know the sum of this. Right, then in this case, we will take this minus of this. And what do you get? You get 7. Yeah, which is exactly the sum here. So essentially, that's the idea for prefix sum, and then it just depends on how you want to calculate the sum of a particular subarray. So the way that the LeetCode editorial is doing it is they are handling the 0th case where the left is here and the right is here, right? So we know that this is the cumulative sum, but then we have to minus this. But if we minus this, then you realize that, hey, 14 only represents this. So you have to add this back, which is basically, which is basically what I'm doing here in this case. Take the right minus the left, and you add the one that you excluded, because in this case you're handling for the 0th case. So I hope that makes sense, and yeah, that's it for this video. Thank you for watching, and let me just show the solution here. All right, and have a great one ahead. Thank you.